Hi, everybody. My name is Dan Lindsay from NOAA NESDIS. Welcome to the Satellite Book Club Seminar Series number 234. Today's presentation is titled Toward a Fire-Ready Nation, an overview of the wildfire portfolio under the Bipartisan Infrastructure Law. Our presenter today is Matt Mahalik from GSL, and our facilitator is Chris Smith, the GOES-R Satellite Liaison to OPC and WPC. A few quick reminders for everybody. The session is being recorded per the OCIO Privacy Act guidelines. Attendees will not have the ability to use their microphones or webcams. Please see the pinned message in the chat for more info. We're going to have a Q&A session after the presentation. I would encourage everybody to post your questions in the chat and they will be fielded there. If you're logged in under an alias, please sign in with your full name or specify your full name when asking a question in the chat. We're always looking for future presenters. Please contact the Tower S team if you're interested in presenting. And if you are interested, fill out the form that should be posted in the chat. The training team can help with training materials that may be unavailable. Please contact Ross Van Til for more information on that. Thank you to OCLO, the GeoLeo programs, and today's facilitator, Chris Smith. So again, our presenter is Matt Mahalik, who is the chief of the GSL Global System Laboratories Mission Support Branch and lead of GSL's Program Management Office, where he leads the organization, coordination, analysis, and project management activities for GSL's research portfolio in support of the Office of the Director. Matt also coordinates NOAA's wildfire research under the Bipartisan Infrastructure Law. He earned his BS in Meteorology from Penn State, an MS in Atmospheric Science from Texas Tech, and previously worked at the NOAA Weather Program Office and the Cooperative Institute for Mesoscale Meteorological Studies at NSSL. Matt, welcome to the Satellite Book Club.
Hey, thanks so much, Dan. And what an honor it is to be here presenting to you all. So I got an invitation not too long ago to present to this group, and I'm glad you're all interested in learning a little bit more about the wildfire work that's happening under the BIL. You may also be familiar with IIJA. That's just another term for the same group of projects here that I'll be talking about. This presentation is just really a kind of a repeat of what I presented at the AMS annual meeting in January, with a few extra, I guess, results thrown in since that time. So I guess before I get going, I don't have an introduction slide because I think at this point, everyone on this call is really familiar with just the overall threat that wildfire poses. And it's really emerged as a year-round threat in this country. Both due to the fact that we're expanding our footprint in terms of where we live and where we work, and how much smoke gets thrown into the atmosphere. I think probably the majority of people in this country have had some sort of impact as a result of wildfires, whether it was just because of a direct fire event or because of the smoke downstream. So that's kind of the motivation behind kind of a renewed focus on building a fire-ready nation in NOAA. So you can go to the next slide, please. So a little bit of background on NOAA's approach to fire. This is a relatively recent development from the last 5 years or so, kind of formalizing a 5-step strategy that NOAA wants to take. And there's not really a first and last step. This is kind of a continuous circle of events here that are working in harmony, looking to engage users, the people that are actually using the data that are out in the field, deploying and leveraging new observation systems, so getting new systems out into the field, leveraging new technologies that are emerging so that we can actually collect new information, understand how fires work and how all of the fire weather that feeds into fire events happen. Advancing the prediction, so that's including assimilating the observations into some of the prediction models that are being developed and enhancing the ones that already exist. Accelerating the development of targeted decision support tools. So that's actually taking the model information, taking the observations and getting them into the hands of the forecasters and decision makers. And of course, equipping the decision makers with new technology out in the field. So I'm going to be mentioning a few different times the Weather Service IMETs, or the incident meteorologists, out in the field. It's been a priority to make sure that they have the information that they need to help people on the ground as well. The next slide, please. Okay, and you can click a couple times till the purple box pops up. That's perfect. So what we've done here is look at projects and design projects around what the user needs truly are. So instead of maybe some of the traditional approaches. In NOAA, we use the readiness levels. We're looking at things that are higher readiness level, things that we can advance to the users as quickly as we possibly can. We're trying to think really from all the way at the end of the value chain, people that are in the field, between the incident commanders, emergency managers, fire chiefs, and fire bosses in the field. What do they need, and how can we provide it? So that's including information that's coming to them from the operational forecast community, the meteorologists and forecasters that are out there. So what do they need in terms of the tools and the various applications to get the information to the commanders and fire bosses? Well, the information that goes to them comes from the R&D community. And so at the labs and other research organizations, we want to be able to facilitate the cutting edge science that advances the tools that forecasters can provide information using. So it really is just a continuous value chain that we're keeping in mind here and designing the projects around. And I've intentionally incorporated the little social science boxes in between each of these, because the communication that happens between all of these different communities is critical, and the social science groups are able to help us understand the best way to communicate all that information. So that's a key cog in all of this, and we've tried to integrate that into most of the work that we're doing here. Next slide. Okay, then going into the BIL itself. So there was a massive investment across the board for NOAA through BIL, and in particular in the climate data and services sections, there are two provisions that are specifically focused on wildfire risk reduction. Coming to NOAA was a total of $100 million, and that was split evenly between operations and research funding, or ORF if you're in the weeds there, and another $50 million for procurement and acquisitions, PAC funds. These projects receive funding FY22 through FY24, with work going on as long as FY28. The caveat that I do have for right now is obviously any changes to future spend plans may impact the end result of some of these projects. A lot of the work has actually already completed. Some of the projects have delivered, and that's great to see. So there's a total of 24 projects that were designed with this $100 million investment. And those projects are led by NOAA Research, or OAR, the Weather Service, and NESDIS, or some combination of those three line offices. You can see the graph I have on the right there just kind of shows the funding breakdown between both the BIL/IIJA, again, same thing, and the disaster supplementals that preceded it by a couple of years. You can see the rough amount of funding that went to each of the 5 priorities that we talked about a little bit ago. And the 5 key focus areas that we really designed the projects around and selected the potential projects around align with the 5 key points in the strategic plan. So the 5 key focus areas of R&D are developing new observing systems, equipping the forecasters with critical data, advancing early detection tools and forecast systems, developing decision support tools, and engaging the fire community. We've also done some communications work just to get the word out about what projects are happening and the values that they're providing. So we have a story map out there. If the slides are shared later, that's a working link. Otherwise, you can definitely go to GSL's website and search for the story map on there. Next slide, please. Okay, so why am I the person that's kind of helping to coordinate this and talking to you right now? So I'm representing the Global Systems Laboratory out here in Boulder, and GSL provides oversight for the wildfire portfolio on the R&D side of things, because we've been trying to establish ourselves as really one of the authorities in fire weather research on the OAR side. So just some quick, recent accomplishments from GSL, because I can't give a presentation without talking about some of the benefits that we're providing to the rest of NOAA and the community. So we focus a lot on high resolution and rapid refresh forecast systems. So more accurate wind forecasts have been a major priority in GSL modeling realm, especially recently. And in fact, the high resolution rapid refresh, or the HRR model, was cited by the Boulder Weather Service Forecast Office to issue the high wind warning that preceded the devastating Marshall fires a few years ago. And so we are continually trying to improve the capabilities of these forecast systems. And just a couple of recent kind of brand new developments, a new wildfire potential index that's updated every hour the first smoke forecasts as part of the HER smoke forecast system, and brand new smoke and dust forecasts that are being integrated into the Experimental Rapid Refresh Forecast System, or RRFS. These are some brand new advancements. GSL is proud to work with a number of labs, Weather Service, NESDIS, NCAR, and a whole host of partners to work on these projects. Next slide. Okay, so now we're going to dive into the BIL projects themselves in a little bit more detail. This is just a quick kind of overview of where the work is taking place. So there's some overlap here. So for example, a lot of the labs are co-located with some of the cooperative institutes, but really I want to highlight just, again, the collaborative nature of all of this. We have OAR laboratories, we have national centers at the Weather Service, and we have NESDIS groups that are working with the cooperative institutes, with external partners who are receiving NOAA funds as part of the overall BIL portfolio. And I have some red markers on there as well to show some of the locations that are actually receiving some of the direct benefit or where some of the work is taking place. And since this map was originally generated back a few months ago, I'll also just note that there are some additional study areas that have been identified in the last really just month or two in New Mexico, New York, and Texas. We've been looking at deployment sites for new instruments in California, Colorado, Idaho, and Nevada, and even a subaward for one of our social science research projects to the University of Oregon. So there's been even more geographical spread of the kind of where the funding is reaping benefits. Next slide. Okay, so pretty much for the rest of this presentation, I'm just going to go through what the projects are. So there's, like I said before, 24 total projects. A number of them have finished, and I'll talk a little bit about some of the specific accomplishments at the end. But just kind of going group by group here. For the new observing systems, a key priority was uncrewed aerial systems. So there's been a gap in collecting data very close to fires. And so a new investment by multiple labs here is actually procuring a number of different uncrewed systems technologies and getting them out to the field. Fixed site observing stations. We're looking to deploy as many as 4 with the funding that we currently have, suites of instruments purchased by several different labs out in the West. So that's 4 different locations that for the first time ever will have this unique combination of observations being taken, both of the soil, of the incoming solar radiation, the boundary layer characteristics. So we're really excited about the potential that those have shown so far in initial testing before the deployments. And for the mobile observing systems, if you're familiar with NSSL's clamps trailers that go out to the field, we're building 2 more of those. They're right outside here downstairs, outside the facilities here in Boulder, and coming together really nicely. Those are effectively going to be kind of simplified mobile versions of those suites of instruments that are going out to the fixed sites, but ones that can be deployed pretty much any time in any location, as long as the roads are good enough for the trailers to get there. And a new mobile radar as well is being delivered to NSSL with a specific purpose of being deployed out to burn scar locations and monitoring precipitation. Because we're not just looking at the pre-fire conditions and during fire, but then also what's happening after the fire is a major, I think, gap in our understanding of the processes, and can lead to major flash flooding incidents. Okay, next slide. Improving the infrastructure. So it wouldn't be the Bipartisan Infrastructure Law without some kind of infrastructure improvement. And this has been, we've had some major advancements in weather service infrastructure that was funded by this. The data infrastructure. So the system that handles the geostationary weather satellite antenna systems, the GWSAS. That's been refreshed, redesigned, and improved, streamlined, and those systems have actually been installed and are online now. And some of the computing machines that are mission critical for handling data, especially satellite data, have also been refreshed and entirely replaced. A lot of those systems were nearing the end of their life cycle, so it was really critical to get those in place. For forecaster access to the data, Weather Service has been using a couple of their projects to transition the forecaster interface, AWIPS. A lot of you are familiar with AWIPS. getting that into the cloud. And so I think I've seen a couple of different cool videos that Ken Graham has put out about how amazed he is that you can get the AWIPS on your cell phone if that was configured the right way. That was funded through the BIL funds to make that happen. And modernization of the ASOS systems, the National Observing Surface Systems, and the updated dissemination of the data that's coming from those. And then also, I've mentioned a couple of times the people that are out in the field. The spot forecast system allows folks to request specific point forecasts from different forecast offices. And so the redesign of the new web-based spot forecast system is in place, funded through BIL. Next slide. Okay, the modeling side of things. So one of the key gaps that OAR has really always faced is the lack of sustained support, long-term support for a lot of the modeling work that happens here. And so BIL committed multiple years of funding to advance the forecast systems that we have. So we're looking at high resolution, short-term modeling, specifically of the fire weather variables, the behavior of the fires after they start, and the smoke and dust, as I mentioned before. Development of a 3D and 4D real-time analysis model. So if you're familiar with RTMA, the real-time mesoscale analysis, working on a 3D and a 4D RTMA, looking kind of long-term into the future as one of our goals. And probabilistic forecasting of flash flooding near burn scars as well. So that's something that OAR and Weather Service are collaborating on, especially the folks over at MDL, trying to understand what is the best way to input a lot of different data sources and come up with what is the probability of rain exceedance and incorporating different soil and surface characteristics. A lot of things go into that. Air quality, of course, I think until recently, air quality and smoke and dust have sort of been neglected in the whole scope of fire hazards. So we've invested a lot into satellite-based detections of fires and understanding the different types of fuels that are burning, because those will have different types of emissions and can cause different health hazards down the line. And of course, the integration of some of the high resolution dust and smoke forecasts that have been experimental, getting those into the operational systems. Climate connections. So a lot of the work that's happening, for example, at the Physical Science Laboratory here in Boulder, working to understand a little bit better about the connections between long-term, talking weeks, months, and seasonal forecasts, and understanding their impacts on wildfire risk. Can we have longer-term forecasts to better understand when and where there may be heightened wildfire risks well ahead of time? And exploring different AI algorithms to take a lot of that information, predict wildfire ignition and predict the behavior of the fires just based on land use. A lot of that information satellite derived as well. Next slide. Okay, and then moving into decision support, really driving action. So this is now getting the information to the people who will use it kind of out in the field. GSL is advancing decision support tools through tools like DESI, the Dynamic Ensemble-Based Scenarios for IDSS. I think I finally got that acronym memorized, which is great. Fire weather testbed is a huge piece of this, and it's kind of a shame that I only have one little bullet there to talk about the testbed. But that's been an incredible thing to see grow over the last couple of years, bringing people from multiple disciplines together, talking about people from Bureau of Land Management, Forest Service, emergency management communities, forecasters and researchers. It's been great to see all that come together and talk about different techniques to communicate risks and get the word out. Of course, satellite techniques, forecasting, detecting, monitor fire ignitions. I think I saw Mike Pavlonis pop on, so that's great in case any questions arise. I'll leave the hardcore science responses to him, but I'll talk a little bit more about some of the advancements from the next gen fire system in a little bit. And then integrating the data and display systems, interrogation techniques, getting those into operations. We've been starting to work with Weather Service on getting transition plans in place, and just getting the cutting edge work into the forecasters' hands as quickly as we can. Social science and public engagement is a key part of this, of course. I mentioned before, we have a handful of social science studies that are taking place, understanding how different communities can respond in different ways to similar types of risk, and also just really getting education out there and communicating to different communities and understanding how they mitigate and respond to events. And engaging the community. We also supported through the Weather Program Office a number of research grants that contribute to community modeling systems that are under development in the UFS. And the Earth Prediction Innovation Center, or EPIC, received some funding as well to help facilitate some of those contributions and get them transitioned. In fact, we just recently, in the last couple of weeks, released the short-range weather application as part of UFS, totally community-based, and it's the first UFS applications that include fire and smoke and dust forecasting capabilities to the research community. And next slide. Okay, so those are the projects. I know it's a lot, and any one of those projects could probably be their own presentation like this. I'll just highlight a couple of the accomplishments, these key accomplishments here. I mentioned the spot forecasts. That's live. So you can go online, look up the spot forecast system. You can see all the live and archived spot forecast requests. It's a really slick display, and I think it's already showing benefit. We've already seen that get incredible usage throughout the California fires, especially in January, and seen a lot of examples of local WFOs being able to communicate with emergency managers, first responders out in the field through spot forecasts. The next gen fire system is, I mean, it's a huge advancement. Everyone I talk to about this is extremely excited to see where this will go. And we're at the point now where these satellite products are actually being used to detect some of these fire ignitions before even the first reports come in. Before the first 911 calls, we have the hot spots and able to get a lot of the fire characteristics ahead of time. And I believe the last number that I saw was 108 forecast offices have subscribed to this system in AWIPS already since it went live in February. That's fantastic to see. And the fire weather test bed. So again, this is another thing I could go on and on about, but the first in-person evaluation at the fire weather test bed was of the next gen fire system. And that occurred in June of 24. And one of the participants used the phrase game changing. And so that was really rewarding to see. I know everyone involved put in a ton of effort, and we're already reaping the benefits from that, I think, and seeing some of the advancements from the fire system. And then I mentioned before the short range weather application release. So some of the first releases in the UFS of smoke and dust applications. And the recent release that happened just this month, April 25, represents a major step in unifying some of the UFS fire and smoke modeling capabilities towards the rapid refresh forecast system that we're developing eventually to be used in weather service operations, assuming all goes well. So those are some of the key accomplishments. And I guess I have one more slide, I think, after this. Yeah, just to kind of wrap up, put a bow on things. We can leave this up. I'm not going to go through everything. These are the official titles of all the projects. So if there's something that really jumps out at you and you're interested in learning more about, absolutely let me know. But this is kind of the highest level overview I could possibly give of all the work that's been happening across multiple line offices, multiple labs. And it's great to see the investment and really the advancements that we've seen since then. So if I misspoke or said anything wrong, I think there's some people on the call who are more knowledgeable about the projects than I am, and I'm happy to have them correct me. But I'll stop talking here and see what kind of questions you all have. So thank you.
Thanks, Matt. I'll take over now. So I will encourage attendees to please stay on for the discussion, including field forecast offices and regional headquarter offices. And I encourage everyone to change their meeting layout to tiled and select hide tiles without videos. So in a week from today, on Thursday, May 8th at noon Eastern, we will have Randy Graham and Jenny Pittman from the Central Region Science and Technology Integration Division discussing remote mesoanalysis support and some of the satellite imagery they use there. If you have any questions, you can contact the TRS team Kashald Bowman and Emily Maddox for questions about the Satellite Book Club or configuration of satellite products. So you can use the chat to submit questions. I will get us started here. Great presentation. Coming from the Weather Prediction Center as a satellite liaison, where we really care about heavy precipitation over burn scars, I was curious about those new mobile observing systems that will be deployed near some of those areas. Do you know if those will be deployed to a certain burn scar for a whole season, or they'll move depending on the forecast? Do you have any information on that?
Sure. So yeah, those are, of course, some of the things that are dependent on some of the future strategies of the agency. But the idea is that it would be flexible to the needs, and that would be to the needs of specific impact areas, to specific forecast offices that are looking to get additional information. It's possible that those could be semi-long-term deployments in certain areas that maybe were hit especially hard by a fire event. But there is also the added flexibility to kind of move throughout the season as well.
Perfect. Yeah, I know that a lot of our, even lighter rainfall events, if there's a burn scar, we saw flash flood emergencies and things like that last summer. I'm thinking about the New Mexico case in particular. Another question I had, all these great projects going on. We know, forecasters are loving the NGFS and AWIPS, for example. Have you heard from the emergency manager community kind of in that value chain that they're seeing some real differences and success stories coming out of this work that's been done?
Yeah, we've been getting a ton of positive feedback. And in fact, I know that NOAA Communications is working on a story that will hopefully come out here in not too distant future that talks about some of the benefits, especially one example with recent fires in Oklahoma. A lot of the folks there have absolutely been chiming in and talking about just the added lead time is invaluable. The early detections, getting people notified, as I said before, even before the first 911 calls come in, is really incredible to see.
Yeah, and I see that in the chat, definitely on the NGFS. That's something I'll definitely have to look into more, looking for the AWIPS here at the National Centers. Are there any key projects, I guess, that are underway now that really want to be, some type of deliverable before the next fire season really begins to ramp up that you know of, or just a variety across all the 24 different projects?
Yeah, so I mean, I think the biggest things that have happened was getting a lot of that infrastructure replaced. So on the Weather Service side, it may not be super flashy, but just getting the engines to ensure that the data flows consistently is great. I know there was some concern a little bit about potential hardware failures, and that would be the last thing that we need to have happen during major events. And so the fact that we were just able to get those installed nationwide was great. So that alone, I think, is a major accomplishment. But I think also this is going to be a great opportunity for some of the new data display systems that are going to be available at some of the forecast offices, especially some of them are kind of under initial evaluation. I mentioned the DESI tool before. Some of the fire forecast systems, the model data, we're hoping to get into those display systems. So if your forecast office has access to DESI, then hopefully we'll be able to get some fire prediction tools in there too.
Thank you. Yeah, great answer. And Ben has a chat and a comment. Where do I access the NGFS dashboard? I think you said Mike's on the call, so maybe he'll be able to provide more information in the chat there. Yeah, and one other thing, it looks like he put it in the chat. The fire weather test bed, I know that, with the schedule, is that still scheduled to happen this year? Are there any more details on, what that's looking like?
Yeah, the team is hard at work, I promise you, very hard at work, planning activities for this summer. And so I think within probably a couple of weeks, we should have a formal report out talking about last year's evaluation. As I mentioned before, that was the first evaluation that was done in person, and that alone was an incredible accomplishment. Yeah, there's going to be some additional evaluation, I think, of some new capabilities with the next gen fire system, with some other partners too. So it's going to be, I think, following the very similar vein in looking at the integration of forecast models, satellite information, and then the communication with getting warnings out and working with collaborators.
All right, sounds like a great opportunity. And we did have a question in the chat there. If NGFS has any capabilities outside of the CONUS domain, like Alaska, and how would they subscribe? So maybe the TowerS team or Mike might have more questions on that as well. So I'll leave that for a moment. If there are any other questions, put them in the chat there. Otherwise, I think that's all I had. So I can pass it back to Dan here in the next couple minutes. And thanks for the great talk, Matt.
Absolutely. Thank you.
Yeah, we'll hang on maybe another 10, 20 seconds to see if there's any late questions.
All right. Yeah. The dashboard covers Alaska with GOES, and there's VIIRS-based detections are available for evaluation this fire season. So Ben Bartos can provide more info, and Lee Byerly from the TowerS team will reach out to the office to get that subscription set up for AWIPS. So it sounds like that's all figured out there. Thank you for answering those questions in the chat, Lee and Mike. All right, Dan.
All right, so I think we can wrap things up. Matt, thanks again for presenting at the Satellite Book Club today. It was really interesting and informative. And thanks, Chris, for your excellent facilitation. As previously mentioned, please mark your calendars for a week from today when Randy Graham and Jenny Pittman from the Weather Service Central Region Science and Technology Integration Division will discuss remote mesoanalysis support revolutionizing severe weather operations through mutual aid. Thanks, everybody. Have a great week. Talk to you next week.